Hi all, welcome to Kotta channel. In this video, we are going to build a loan approval prediction machine learning model for the financial organizations. Banks and financial organizations receives a lots of loan requesting applications in a single day. So they have to process all these applications and take the action on those applications, whether the applicant loan is approved or rejected based upon their financial status. So this machine learning model is going to help them to make this process very quick and effective. Let's see the demo first. So here is the final web application looks like loan prediction app. So here we have couple of inputs that we have to give. So once we give all the inputs, when we click on this predict, so this machine learning algorithm in the backend processes this data and then it gives the two outputs, whether the loan can be approved or whether the loan is rejected. Okay, let's give some details first. Number of dependents as to graduation is graduated, self-employed, no, he's not self-employed. Annual income, yes, 25 lakhs, and loan amount is 75 lakhs. Okay, and duration is close to 15. Yeah, and CIBIL score, I wanted to give a good CIBIL score, 780 800. Yeah, assets worth, yeah, 80 lakhs. Let's click on predict. So loan is approved based upon the input data set that we have provided. The loan is approved for the applicant. Okay, let's make some changes and then see. I just want to change this loan duration to 5, and I just want the CIBIL score to poor, and assets to just 20 lakhs, 24 lakhs, and annual income reduce it to 15. Okay, and try now. Okay, predict. Loan is rejected. Okay, so based upon these values, our model is going to predict whether the loan can be approved or whether the loan can be rejected. Okay, this will expedite the process for the financial organizations or banks to process the huge number of applications in a short span of time. The first thing before building a machine learning model is we need the data set. So once we have the data set, we need to do the cleansing of the data set and we need to do the analysis on the same data set. So once we are done with this process, we are going to split the data set into two parts. First part is called training data set and another part is called as a testing data set. 80% of the whole data set goes to the training data set and 20% goes to the testing of the data set. So once we are done with this data set completion or splitting and everything, once we are done with the data splitting, then we are going to create the machine learning model. So the model which we are going to create here is logistic regression machine learning model to predict the loan status based upon the certain inputs from the user. So once the logistic regression model is created, we will be training that model with the training data set. So once the training of the model gets completed, we will be evaluating that model performance with the test data set. So once we are good with all this process, we will be saving this model and will deploy it as a web application, as you guys have seen in the demo part. Let's dive into the coding. Here is the folder I have created, loan approval prediction, and here we have a source dataset as well. So let's open the Jupyter Lab first. Okay, our Jupyter Lab is up and running. Now let's create a new file and let's rename this notebook as loan approval prediction model. Okay, now let's import the libraries. So the libraries which we are going to require for this application machine learning model is, one is pandas. You guys can type pip install pandas, and second one is scikit-learn. Okay, so these are the two models that we would need to develop this machine learning model for the loan approval prediction, and to deploy it as a web application we need the Streamlit, and to save the model we need the pickle. These are the four Python libraries which we would require to create this machine learning model. So you guys just open your command prompt and type in pip install these library names and press enter. These libraries will get installed. I have already installed these libraries in my system, so I'm not going to install them again. Okay, let me import it. Import pandas as PD. Okay, let's read the input data set first. Data is equals to pd dot read csv, and here is the file. Let's copy the file path, copy the path, single quotes. Okay, let's see the data. So here is the total data. So we have 4269 rows of data with the 13 columns. Okay, and let's take a look at the each and every column. So first one is the loan ID. So it's like a unique number for each and every row. And next one is the number of dependents or number of people dependent upon the applicant. Okay, and the second one is education. So whether that particular applicant is graduated or not graduated. And next one is whether that particular applicant is self-employed or not. Okay, and next one is the annual income for the applicant and the amount he is requesting for a loan, and the next one is loan term. Okay, the duration of the loan, it's in years. Okay, and it starts from 0 to 20 years ideally. And the next one is the CIBIL score. So as you all know that CIBIL score plays one of the important role in a loan getting approved. Okay, next one is the residential assets value of the applicant, and commercial assets value and luxury assets value and bank asset values, and these are the assets. Okay, and finally loan status, whether that loan is approved or rejected. Okay, this is the past history. Okay, based upon this data we are going to create the model. Okay, now we have the data set. Okay, now what we are going to do is let's do some analysis on this data. Okay, first we don't need the loan ID column, right? Okay, let's remove that column first. Data dot drop columns is equals to loan ID. Okay, and it's not going to give any importance, right, this loan ID while evaluating the loan. Okay, I'm just doing that. Just data dot drop column name I'm just giving in place is equals to true. That means it will be applicable on this data set itself. Okay, now this is gone. Okay, now we have number of dependents, education, self-employed, remaining things. And here if you observe, let's see the data dot columns. Okay, and if you see here there is a space before every column name. Okay, let's remove that. Okay, data dot columns, what I'm going to do is data dot columns is equals to, let's strip those columns. Okay, data dot columns dot strip string dot strip. Okay, now let's print this data columns. Okay, if you observe here, so this extra space in the starting is gone now. Okay, now this data cleansing of the columns is completed. Okay, now let's print the data set. Okay, here is the data set, and next step is, if you see here, these residential, commercial and luxury and bank assets, so all these are assets, right? So we don't need to have it as independent columns. So let's club all these columns into a single column called assets. Okay, data dot columns, I'll just print them here. Okay, now data of let's create a column called assets. Okay, now data dot residential column, residential assets value, plus data dot commercial, next data dot luxury, right, luxury assets, next data dot bank assets. Okay, so let's print the data set now. Yeah, now we have added extra column called assets, right? So we have created assets column. Now we don't need this column, so let's remove these columns now. Okay, data dot drop columns equals to, one is residential assets column, and next one is commercial one, and the next one is a luxury one, and next one is bank asset values. Okay, just removing them. Okay, and I'm just wanted to apply this action on the same data set, right? That's the reason in place is equals to true here. Okay, it's done. Now let's print the data. So here is the data. We have 9 columns now: number of dependents, education, self-employed, annual income, loan amount and the term of the loan, CIBIL score and loan status and assets. Okay, now what I'm going to do is so as a next rule, so to improve the performance of the machine learning model, what we are going to do is we are going to convert this alphabetic or string values into the numeric values. Okay, let's convert those. Let's print what are the distinct values. Okay, here we have three columns, I guess, right? Education, self-employed, and loan status. So these are the string columns. So let's convert them into numeric values. So before going that, let's check if there are any duplicate values in this in the data set. Okay, is null dot sum. Okay, we don't have any null values. Okay, so then we are good. So if there are any values, if there are any null values, then what we have to do is we have to apply this drop in a function, and in place is equals to true. So it will remove the if there are any null values or missing values in the data set. As we don't have anything, so we don't have to execute that. Okay, now let's print the whole data set. So here is the data set and here is the column. So now let's see the distinct values in the education. Okay, data dot education dot unique. Here if you see here, there's an extra spaces in the columns values as well. Okay, let's remove these extra spaces for all the columns. Okay, for the entire education column. Okay, and definition of clean data, and let's take an as st as input. St is equals to st dot strip, stripping that column values, and return st. Okay, let's execute it now. Clean and score data. Let's copy paste and see how it is going to work. Okay, see, it's removing this extra spaces. Okay, now let's apply this for the entire column of the education. Okay, data dot education is equals to data dot education dot apply of clean and score data. Okay, now it has been applied. Now data dot education dot unique. Okay, so now these extra spaces are gone. Okay, now let's replace this graduate and non graduate with the numerical values. So what I'm going to do is data dot data of education is equals to data of education dot replace. Okay, and here we have two values. Okay, graduate and non graduate, right? Let's copy paste it, and here what I'm going to do is 1 comma zeros. Okay, that's done. Now let's see for the data. So if you see here, now the education column has been replaced with the ones and zeros. Okay, 1 means that applicant is graduated, 0 means he is not graduated. Okay, let's do the same for the self-employed and the loan status as well. Okay, quickly, data dot self-employed dot unique values. Okay, let's see this unique values. So here also we have yes or no, and here also there are extra spaces. So let's remove them with the function which we have written earlier. Okay, self-employed is equals to data dot self-employed dot okay apply and clean data. Okay, data dot self-employed dot unique. Okay, now yes or no. So we have removed the extra spaces in the data. Okay, now let's replace this data dot self-employed is equals to data dot self-employed dot replace and this no comma oh, no comma yes with the 1 comma zeros. Okay, 0 comma 1. Okay, it's done. Now let's see the data. Now self-employed column is also replaced with the zeros and ones instead of the alphabet. Now self-employed column also replaced with the ones and zeros in place of the string values. Now let's do the same for the loan status as well. Okay, data dot loan status dot unique values. Okay, we have two unique values, one is approved and one is the rejected. Here also extra spaces, so let's apply the clean data function. Loan status, so data dot, so when you return the function, so it will be help to apply for the all the columns, so you don't have to do the coding again and again. Okay, clean data, so it's done. Now data dot loan status dot unique values. Okay, so we have approved and rejected with the clean data and remove the extra spaces. Now replace them. Okay, loan status is equals to data dot loan status dot replace. Okay, what we are going to replace, approved and rejected with ones and zeros. Okay, 1 comma 0. Now let's print the data. So here is the final data. So with the 9 columns: number of dependents, education, self-employed, annual income, and the requested loan amount, and the term of the loan, and CIBIL score, and the loan status, and the assets. So here is the complete final data. And now we are good with the data. Now what we are going to do is let's split this data set into training data set and test data set. Okay, for that one we need the scikit-learn model from sklearn dot model selection import train test split. Okay, and before splitting it out, just these are the total 9 columns are there, right? So this column is the output column and remaining 8 columns will become the input data set. So let's split the data set into input data set versus output data set. Okay, data dot drop columns equals to loan status, right? Let's copy here and paste it. Okay, and output data is equals to data of loan status only. Okay, we need the loan status alone as output data. Okay, we are done with the input data set and output data set, right? Input data with 8 columns and output data with only 1 column. Okay, okay, now we have the input data set, output data set. Let's split the data set into train, test data splits. Okay, for that one what I'm going to do is x train comma x test data set, y train comma y test data set is equals to train test split. So we have to pass the two arguments to it. One is input data and another one is the output data. Okay, and test size here. So how much is the test size? So 2% of 0.2, in the sense 20% of the data set goes to the test data set and remaining 80% will be remaining it as a training data set. Okay, now splitting of the data set is completed. Now we'll see that x train dot shape x test dot shape. Okay, so 3415 rows will become the training data set and 854 rows will become the test data set. Okay, similarly you can print the same values for the y train and y test as well. Okay, y train dot shape and y train dot test shop dot shape. Okay, same 3415 output columns and here 854. Okay, so now we have split the data set into training data set and test data set. Okay, as if you see here in the data set we have having the large number of amounts, right? Like crores and lakhs and everything will be there, so there will be outliers. So we have to do the scaling of this data. Okay, scaling of the data will improve the performance of the machine learning model. Here we are going to improve the performance of the model by scaling the data with the standard scaler. Okay, this standard scaler functionality will be available in the sklearn only. Okay, scikit-learn, sklearn, and pre-processing import standard scaler. Okay, let's create an object for this one, scaler. Okay, once the scaler is created, now scale the data. X train scale dataset is equals to scalar dot fit underscore transform of x underscore train data. Okay, it's train scale. Now same way x underscore test underscore scale is equals to scalar dot transform and x underscore test dataset. Okay, so scaling of the input dataset is completed. X train scale and x test scaled. Okay, now let's create the model. Okay, for the model we need the logistic regression, right? So let's import that from the scikit-learn. sklearn dot linear model import logistic regression. Okay, let's create the model with the logistic regression. Model is created. Let's fit the model with the train dataset. Okay, we are going to train the dataset here, right? X train scaled comma y underscore train. Okay, so our model is created. Now let's do the predictions. Okay, let's evaluate the model score with the test dataset. Okay, model dot score um, x underscore test comma y underscore test. So it's printing 59% of this user warning x as picture names but regression is fitted without claims. sorry, here X test scaled I have to use. The accuracy of our model is 91%. I think it's really good. Now let's predict some values. Okay, predict data. Predict data is equals to, let's predict some values. Okay, pd dot data frame, and for this one, for the columns is equals to, okay, what I'm going to do is, let's, we need these column names, right? Mm, let's copy some values from here. Okay, now our input data set is done. Let's scale this data set. Scalar dot transform of predicted data. Now let's predict the value. Okay, model dot predict of this predicted data. Okay, so RF1, so loan is getting approved. Okay, I think for the first row, I think the status is approved only. See here, with these input set, with these input data set values, I think our loan status is printed as a approved. Okay, so our machine learning model is working perfectly fine. So this is how we guys can create a machine learning model. So let's take a look at the first things. Okay, first we read the data. First we read the input data set and we remove the loan ID column, and we have seen the list of the columns, and each and every column name is having an extra space. So we have stripped those column names. Okay, now we are got the columns without any extra spaces. So now we have the data. So we have added the columns of the assets value with the residential, commercial, luxury and bank assets. So once the addition of column called assets has been created, then we have removed this all these four columns which are used to create this assets column. So now we are left with only 9 columns. Out of 9, 8 are the input columns and last one is the output column. Okay, and we checked for the null values. We don't have any null values, and we have stripped the data in the data set. Okay, for the extra spaces for the string columns. So that has been done, and then we have replaced the values with the ones and zeros for the education column, self-employed column, and then next for the loan status as well. So once all these things done, then we have split the data set into input data set and output columns. So once that is done, then we have split the data set into input data set and output data set. Then we have scaled our data with the standard scaler, and once the scaling of the data is completed for the input columns, then we have created a logistic regression machine learning model. So once the model is created, then we have trained our model with the scale data of input data set and the output data set of training data set. And once that is done, then we have evaluated the score of our model, which is coming close to 91%. Then we have predicted the values with our model by giving the random input numbers. Okay, now our model is predicting the values properly. Okay, now our model is created. Let's take this step into the next level by creating a web application. Okay, let's save this model. So for saving the model, we need a functionality of the Python library of pickle. Okay, import pickle as pk. Now save this model. Model pk dot dump. So we are saving the model here, right? So model and open model dot pickle and with the right binary access. Okay, yeah, here this model has been created, model pickle, and here I'm going to take another one as well, which is called scalar as well. Okay, and same thing, pk dot dump of scalar comma open scalar. Okay, scalar dot pickle with the right binary access. Okay, so here when scalar has been created, now let's move on to the Visual Studio for creating a web application in Streamlit. Okay, if you see here, we have the two pickle files. One is the model pickle file and another one is the scalar pickle file. And now here we are going to create a app.py file, Python file. Okay, and let's try coding. Okay, import, we need first thing a Streamlit to deploy it as a web application, right? So first we need import of Streamlit. Next we need the pandas. Okay, pandas spd. Next import sklearn We don't need a scale none, I guess, right? So we don't need anything from that. Okay, and let's read the model first. Okay, model is equals to um, pickle we need, right? So let's import the pickle first. Import pickle as pk. Model is equals to dot load. Okay, and open the read binary access. I need this model. Okay, copy. Here I have created model. Similarly, I need the scalar as well, right? So I'm just copy pasting it here, and here I'm going to create scalar. Here scalar dot pickup. Okay, now let me create a heading. Okay, st dot header. So what is going to be the name of this application? Let's give it as a loan prediction app. Okay, let's save it, run in a dedicated terminal. So it's executed. Let's run this streamlit in browser. Streamlit run app.py. Okay, so every streamlit application that we have to type in as streamlit run app.py. So once you enter this command in terminal, if you press enter, so there will be a browser will pop up with the application as a web application. See here, so with the header loan prediction app. Okay, fine. Now let's close this one. Okay, now we have the header. Okay, now we need the inputs from the users, right? So what are the inputs that we need from the users? Let's come here, and we need all these columns, right? Let me copy paste this part. Okay, as it is. And now we have these many columns. Data is required from the users. Okay, let's create that. st dot first one, what is this? The first column is going to be a number of dependents. St dot slider of choose number of dependents. Okay, comma 0 to 10, 0 to 5 dependent should be fine, I guess. Saved it and coming here and always rerun. Yeah, it has given a slider to choose the number of dependents. Okay, 1 2 3 4. Okay, fine. Now next one is the next one is what we need, education. Okay, next thing, select box. Okay, choose education. Okay, here we need multiple values, right? Graduated, comma not graduated, right? Not graduated. Okay, let's save it, check it out. Okay, rerun. Oh, I did not save, I guess. Let me save this application. Yeah, here we have graduated or not graduated. Okay, and here you can go to the settings, run and save. Okay, it will be rerunning the job. It will rerun the application every time when we save this file. Okay, now we have these two, select box. Now we have self-employed as well. Okay, let me copy paste this one, choose self-employment status, self-employed. Okay, this one goes as SR. Now here we are going to create a number of dependents. Okay, and graduation status, and here self-employed. Okay, so these are the values. Now next one is annual income. Choose annual income starting from 0. Let me have it as a hundreds, thousands, 10,000, lakh, 1 lakh, 1 crore. Okay, saying it is annual income. Let me repeat it for the loan amount as well. Loan amount. Okay, loan amount as well, same. Next, loan term, CIBIL score and assets. Okay, loan duration, loan duration 1 to 20 years ideally, right? And next one is assets, shows the assets. Next one is civil score as well. Civil, shows civil score. Civil score 1 to 1000 only, should be fine now. 1 2 3 4 5 6 7 8, 8 columns are there. How many columns? 1 2 3 4 5 6 7 8. So we need to pass them to here. Okay, instead of 2 I have to copy the number of things. Okay, I'm just leaving these two because we have to convert them to numeric values, right? Self-employed and graduation status. And here we need annual income, and then we need the loan amount and loan duration, civil score, final one is assets. Okay, after having everything we have to convert this graduation and self-employed this character strings to numeric values. Okay, if grad value is equals to graduated, then grad status is equals to 0, else grad is equals to 1. Okay, similar for the self-employment as well. Okay, instead of grad here we have to have self-employment is equals to no. Okay, now here employment status. Okay, okay, and here I'm going to copy these two things here. Okay, and employee status to here as well. Okay, saving it now, and let me create a variable here. Okay, button, if st dot button, it's the button now, predict. So once the user enters all these details, if he predicts, okay, then this data is going to be created. Okay, okay, once it is there, let's save it and then see that first. Okay, choose number of dependents, 1 2 dependents, and graduation yes or no, self-employment yes or no, then annual income and loan amount and loan duration and civil score and assets, then click on predict. Okay, and let's add the model. Predict is equals to model dot predict of this prediction data. Okay, before this one we have to do the scaling of the data, right? So we have the scalar read underscore data is equals to scalar dot transform of predicted data. Okay, so once we are done the scaling of the data, we are passing it to the thing, and here if predict of 0 equals to 1, st dot mark down as loan is approved. Okay, let's go to the else mode, else loan is rejected. Okay, let's save this one. So here is the final web application looks like, loan prediction app. So here we have couple of inputs that we have to give. So once we give all the inputs, when we click on this predict, so this machine learning algorithm in the backend processes this data, and then it gives the two outputs, whether the loan can be approved or whether the loan is rejected. Okay, let's give some details first. Number of dependents as to graduation, is graduated. Self-employed, no, he's not self-employed. Annual income, yes, 25 lakhs, and loan amount is 75 lakhs. Okay, and duration is close to 15. Yeah, and CIBIL score, I wanted to give a good CIBIL score, 780 800. Yeah, assets worth, yeah, 80 lakhs. Let's click on predict. So loan is approved based upon the input data set that we have provided. The loan is approved for the applicant. Okay, let's make some changes and then see. I just want to change this loan duration to 5, and I just want the CIBIL score to poor, and assets to just 20 lakhs, 24 lakhs, and annual income reduce it to 15. Okay, and try now. Okay, predict. Loan is rejected. Okay, so based upon these values, our model is going to predict whether the loan can be approved or whether the loan can be rejected. Okay, this will expedite the process for the financial organizations or banks to process the huge number of applications in a short span of time. Thank you all. Thanks for watching this video. If you like the content in this video, please do like and subscribe to our channel.